Hello friends, the subject of data structure and algorithm. Topic will be covered up in this lecture. First, open addressing and second, rehashing. First, open addressing. Unlike separate chaining, all the keys are stored inside the hash table. No hash sorted outside the hash table. Technique used for open addressing are first, linear probing, quadratic probing, and double hashing. Operation in open addressing. First, insert operation. Hash tab function is used to compute the hash value for the key to be inserted. The hash value is used then and indexed to store the key in the hash table. In case of collision, probing is performed until an empty bucket is found. Once an empty bucket is found, the key is inserted. Probing is performed in accordance with the technique used for open addressing. Next, search operation. To search any particular key, its hash value is obtained using the hash function used. Using hash value, that bucket of the hash table is checked. If the required key is found, the key is searched. Otherwise, the subset of bucket are checked until the required key or an empty bucket is found. The empty bucket indicates that key is not present in the hash table. The key is the first searched and then deleted. After deleting the key, particular bucket is marked as deleted. Next, linear probing. When collision occurs, we linearly probe for the next bucket. We keep probing until an empty bucket is found. Advantages of linear probing. It is easy to compute, and disadvantage. The main problem with linear probing is clustering many consecutive elements from groups. Then it takes time to search an element or to find an empty bucket. Example of linear probing. Let's consider a simple hash function hash key modulus 7 and sequence of 5, 50, 700, 76, 85, 92, 73, and 101. Initial empty table, insert the first 50 and then next insert with the 700 and 76 in the position of 0 and 6. Then insert the 85, the occur, the insert at the next free slot. Next, insert the 92, collision occur as the 50, there at index is 1, insert at next free slot, then insert the 73 and 101. Quadratic probe. When collision occur, we probe for the I bucket in the iteration. We keep probing until an empty bucket is found. Next, double hashing. We use to another hash function to x and loop for I into hash to x bucket in I iteration. It required more computation time as to hash function need to be computed. Double hashing is collision resolving technique in open addressed hash table. Double hashing uses the idea of applying a second hash function to key when a collision occurs. Advantages of double hashing. The advantages of double hashing is that it is one of the best forms of probing, producing a uniform distribution of record throughout a hash table. Next, this technique does not yield any cluster. Third, if it one of effective method for resolving collision. Let's say hash 1 key equal to modulo of 30, hash 2 k equal to 7 minus k modulo of 7. The hash 1 is 19 equal to 19 modulo of 13 equal to 6. Hash 1 7 27 equal to mod of 12 equal to 1. Hash 36 equal to hash 36 modulo of 30 equal to 10. 10 modulo of 13 equal to 10. Hash 7 minus 10 modulo of 7 equal to 4. Hash 10 1 plus into hash 2 into 10 modulo of 13 equal to 1. It is a collision. Difference between separate chaining and open addressing. First, key is stored inside the hash table as well as outside the hash table. Open addressing. All the keys are sorted only inside the hash table. Separate chaining. The number of keys to be sorted in the hash table can even exceed the size of hash table. The number of keys to be sorted in the hash table can never exceed the size of the hash table. Separate chaining, deletion is easier. Open addressing, deletion is difficult. Separate chaining. Extra space is required for the pointer to store the key outside the table. Open addressing, no extra space is required. Cache performance is poor. This is because of linked list which store the keys outside the hash table. Cache performance is better. This is because here no linked lists are used. Separate chaining. Some buckets of the hash table are never used, which lead to weightage of space. Open addressing. Bucket may be used even if no key map those particular bucket. Next, rehashing. Rehashing is a collision resolution technique. Rehashing is a technique in which the table is resized. That is, the size of the table is doubled by creating a new table. It is repeatable. Is the total size of the table is a prime number. There are situations in which the rehashing is required. When table is completely full with quadratic probing, when the table is filled half. When insertion failed due to overflow, in such situation we have to transfer entries from old table to the new table by recomputing their position using hash function. The hash table with input 7, 16, 32, 42. As the name suggested, rehashing means hashing again. Basically, when the load factor increases to more than its predefined value, default value of the load factor is 0.75, the complexity increases. So to overcome this, the size of the array is increased, doubled, and all the values are rehashed again and stored in the new doubled size to maintain a load factor and low complexity. Why rehashing? Rehashing is done because whenever key value pair are inserted into the map, the load factor increase, which implies that the complexity also increases, and explained above the might not be the required time complexity of O1. Hence, rehash must be done increasing the size of bucket array so that to reduce the load factor and the time complexity. How rehashing is done: for each addition of new entry to the map, check the load factor. If it is greater than its predefined value or default value of 0.75, if not given, then rehash. For rehash, make a give new array of double the previous size of and its new bucket array. Then traverse to each element in odd bucket array and call the insert for each so as to insert it into the new largest bucket array. Thank you friends for watching this video.